Hello, science students. It's Tanya again. Just going to go over the next lesson. So in your notes package, this should be CA5, I believe, monoatomic ion student notes. So find your way to this. So the first part is relating to the last lesson. So construct the Bohr diagrams for the following atoms. So maybe quickly pause it and do the Bohr diagrams for the two atoms that we have there. So we have fluorine and we have neon. So hopefully you paused it and gave that a try. So I'm going to quickly, so 9 protons, 10 neutrons. Sorry, I have to write pretty small there. Representing our 7 electrons in the second shell. We've already represented 2 in the first, so in total we need to do 9. And for neon, so representing 10 electrons in that neon atom to balance out the 10 positive charges associated with it. So it says, which atom is more stable? So I talked about that in the last lesson, that something that's more stable has its valence shell filled. So again, valence is your outermost shell of electrons. So if we look at fluorine, it has 7 out of 8 spaces filled, whereas with neon, it has 8 out of 8 spaces filled. So neon is actually more stable because it has a full valence or full outer shell. What's the difference between the two? Again, the difference is fluorine has 1 less electron. Fluorine also has 1 less proton, but when we're talking about Bohr diagrams, we're really specifically looking at the electrons. So how could fluorine become more stable? It can't just be like, I want to be like neon and put on a cool neon jacket. So fluorine can become more stable by gaining an electron. So that would fill its outer shell. Again, stability comes from the outermost shell being full. So, oh, sitting on my chair. So remember, the goal of all elements is to become stable. And so I mentioned this last time. If you look at all of the noble gases, they all have a filled valence shell. So if you drew out the Bohr diagram for your noble gases, sorry, I now have a periodic table that I'm trying to open. So if you drew out the Bohr diagram for neon, which we just did, or argon, you could go as far as krypton. It's kind of hard to draw. You would find that it actually has a full valence shell. And so that's very stable. So things want to become like a noble gas. So fluorine's new Bohr diagram, if it gained an electron. So fluorine, a fluorine ion has gained an electron. So in order to gain an electron, or in order to fill its valence shell, it has gained an electron. So if we now write, oh, I'm doing what I said don't do. I was spelling it wrong. FLU, fluorine ion, actually has a different name. It's actually fluoride. So looking in your periodic table, so find fluorine, so it says 9, fluorine 19.00. You'll see at the bottom of that box, it says F minus and it says fluoride. So the name of our fluorine ion is actually fluoride. So when I would draw out the Bohr diagram for fluoride, what it actually looks like, oh, sorry, it has 10 neutrons. Sorry, I'm doing these kind of out of order, but so overall, now we have, again, 2 in the innermost shell, and now we have 8 electrons represented in our valence shell. So for a total of 10 electrons instead of 9 electrons like we had for a fluorine atom. So the other thing that we typically do when we're drawing an ion is we draw kind of square brackets around the side. We write the overall charge that this ion would have. So it's gained an electron, but remember that even though we're gaining something, we're gaining a negative charge. So now this ion will have a -1 charge overall because it has more electrons or more negative charges than positive charges. Sorry, just kind of scanning what we have here. So on to the next part there, it says, some elements may share electrons in order to fill their valence shells. You guys thought I would have stolen Kelty's smartboard by now, hey? That would have been a good idea. So in order to fill their valence shells and become stable, but others gain or lose electrons. So we'll talk a little bit more later about sharing electrons, but right now we're really going to be looking at gaining or losing electrons to stabilize. So when something gains or loses electrons, these elements become what are called ions. And again, ions are charged species. Positive or negative charges associated with that. So monoatomic ions. So mono meaning one, atomic meaning one atom. So monoatomic ions can be either positive or negative charged particles formed from a single atom. If the atom gains electrons, it attains a negative charge. So again, we always think gaining something is good, like gaining money, but when we're talking about gaining electrons, it's actually a negative charge. So if you look in your periodic table above your staircase, the things that end up with a negative charge are your non-metallic elements. So something like fluoride that we just saw ends up with a negative charge, or sulfur becomes sulfide with a 2- charge, or chlorine becomes chloride with a 1- charge. And so what you see is the ending of those when they're in their ionic form, they end with IDE. You have them in your periodic table, so if you don't remember, if nitrogen becomes nitrogenide, it doesn't actually, it becomes nitride, but it is in your periodic table for there. So the example that they kind of have there is fluorine, an atom of fluorine. If it is added to, or it gains 1 electron, it will produce F with 1-, which is your fluoride ion. So again, that name is on your periodic table, so you don't need to worry about memorizing that, but you need to know what that's talking about. So that's gaining electrons, but if we look the other way, if the atom loses electrons, it attains a positive charge. So these are your metallic elements. So these are things below the staircase on the periodic table. So if we look at something like atomic number 12, magnesium, we see that magnesium forms a 2+ ion. So now we have positive charges, but it doesn't become magnesite or something like that. We still call it magnesium. We would just call it a magnesium ion, knowing that it forms a 2 positive charge. So the name of the ion is the same as that of the element. So we don't do any IDE changes at the end. So something like sodium. If sodium is losing an electron, we're going to say that it's breaking into sodium with 1+ charge, and it is spewing off an electron to somewhere. So it's giving up a negative charge to become positively charged. And so again, we would just call that a sodium ion. And so things can lose an electron to become stable. So if you look back, let me scan, 2 pages, more than 2 pages actually, we drew the Bohr diagram for sodium previously. So on the first page of drawing Bohr models, if you flip back, you see the 4th diagram was the sodium atom. And so what you see is if you draw the Bohr diagram for sodium, there is just 1 electron in its outermost shell. So just 1 little electron, there's 7 empty spaces. So instead of trying to find 7 electrons, it's easier for sodium just to boot off an electron. And then what you see is its next shell is the only shell that has electrons in it, its valence shell. So if it boots off that electron, again, it's going to become positively charged. So the next point on your notes here, it says ions will form this same stable electron structure as the atoms of the nearest noble gas. So count up the electrons and see which noble gas the ion looks like, or use the periodic table to see which noble gas has the number of electrons closest to the atom forming the ion. So what this is saying, so if you look at your periodic table, you see fluorine. Fluorine's really close to noble gas neon. Again, your noble gases are group 18. So fluorine will try to become like neon. You see that oxygen is still pretty close to neon. Oxygen is going to form neon. And then if you look at sodium, so sodium is number 11 there. Sodium, if you think of the periodic table as kind of wrapping around, sodium will actually become like neon, that it has 11 electrons in its atomic form. It wants to become like neon that only has 10 electrons. Instead of trying to find 7 electrons to become like argon, it will become like neon. Hopefully that kind of makes sense. I know that's a little bit hard to visualize. So positively charged ions, so things that have a positive charge, if we're talking about your metallic elements, so you see sodium or iron or silver, those all form positive charges, or the positive ions. Those are called cations. Negatively charged ions are called anions. I always think, if we look at cat, there's a big plus in there. So that's how I remember that cations are positively charged. Alana has a cute little way to say cats have paws. So cations are positive ions. So however you want to remember that, anions are your negatively charged anion, or are your negatively charged ions. So those are some terms that you'll need to kind of remember. So the next part, it says the charge of the monoatomic ion depends on how many electrons the atom has to gain or lose to become like its nearest noble gas or to stabilize. So that's saying like how many spaces on the periodic table is it from a noble gas. If it's 2 spaces, it needs to gain or lose 2 electrons. If it's 1 space, it needs to gain or lose 1 electron. So if something loses 1 electron, then it becomes a 1 positive charge. That's something that's really hard to wrap your head around, but you just need to think about how losing a negative charge actually makes something positive. So if it loses 1 electron, then it's positive 1. If it loses 2 electrons, then it's positive 2. And on the other side, if it gains 1 electron, if you're gaining a negative charge, that will have an overall negative charge of negative 1. And if it gains 2 electrons, then it will have a negative charge of negative 2. So that's something that's really important to kind of keep in mind and pay attention to. So let's look at, just to kind of clarify those, let's look at magnesium. So magnesium, if you look at it in your periodic table, it's number 12, has an atomic mass of 24.31. So it would also have 12 neutrons if we were worrying about that right now. So magnesium, atomic number 12, its closest noble gas is neon. So that's atomic number 10. It's closer to 10 than it is to 18, which is argon. So it's going to try to become like neon, is what I'm going to call it. So in order to become like neon, it needs to lose 2 electrons. But let's kind of draw the first 2 things out. So this is our magnesium atom, and this is our neon atom. So maybe quickly pause it and draw your Bohr diagrams for those 2 parts. So again, magnesium atom, neon atom. Draw your Bohr diagrams quickly. So pause it and draw that. So hopefully you've drawn out your Bohr diagrams. So magnesium has 12 protons. Again, 24.31 means it also actually has 12 neutrons. We know that if we're talking about an atom of something, your protons need to be equal to your number of neutrons. My shell is going to kind of go off the edge of the page. So we want to represent 12 electrons. 1, 2, 3, 4, 5, 6, 7, 8. Oh, I drew it in the wrong spot. Let's just throw this up here. I didn't circle my nucleus properly. Sorry, I'm not going to redo it now. You should have a circle around your nucleus and then your first shell. So we have 2, 10. We need 2 more. 1, 2. And then looking at neon. So neon has 10 protons. We know it has 10 neutrons as well, because neon has a mass number of 20.18, which is pretty close to 20. So it will have 1, 2 in its first shell. And then, again, representing 10, it will have 8 in its second shell. So that's what neon looks like. So our magnesium ion, it already tells us what charge it's going to form, but we could actually figure that out without looking at our periodic table. So we know that it wants to have a full outer shell. So thinking about that, the third shell, think about how many electrons can fit in the third shell. It can fit 8. So right now it has 2. So even though this is a weird way of thinking of it, is it easier to find 6 more or to boot off 2 of them? And so you think numbers wise, it's going to be easier to get rid of 2 electrons than try to find 6 electrons. So what it's going to do, it wants to lose Sorry guys, I'm just going to pause for a second. Sorry, I had to pause it for a second there. So the magnesium atom wants to lose 2 electrons to become more stable. It's easier for magnesium to lose 2 electrons than gain 6 electrons to fill its outer shell. So magnesium 2+ is more stable than magnesium as an atom. So drawing the Bohr diagram for something that is 2 positive, we want to lose those 2 electrons. Oh, it won't let me write in color. We want to lose this electron. Oh, it won't let me write in red, but we want to lose those 2 electrons. So let's draw the Bohr diagram of the magnesium 2 positive ion. So you haven't changed your number of protons and neutrons. That's important. To become 2 positive, you can't actually gain 2 protons because then it's no longer magnesium. Then we are talking about silicon. Not what we want to do. You can only change your number of electrons. Sorry, these are weird circles. So we've lost those 2 electrons that were in the outermost shell. So now actually that shell kind of, we're going to use the word disappears, but it doesn't disappear. But now we don't have anything in that shell. So we look into the next shell. So the next shell was filled up with 8 already. Now we've got an empty outer shell. So we ignore that outer space and we look at this. So now what we have is we have 2 shells. They are both full. Again, to represent it, we'll put square brackets around and say it's a positively charged ion. And so what we see now is if we're looking at these 2, they have the same electron configuration. Oops, same electrons, right? Magnesium, I'm doing air quotes right now, magnesium ion looks like neon, right? 2 electrons in the inner shells, then 8 in the next shell, or what's your valence shell. And so there's a little note at the bottom. It says the group number corresponds to the number of valence electrons, indicates how many electrons an atom needs to gain or lose to fill the valence shell. Therefore, it helps to determine the ionic charge for elements in special groups. So if we look at our group 1, so those are your alkali metals. So that's like lithium, sodium, potassium, so on. If you look at those all form a 1 positive charge. So if we drew the Bohr diagram for lithium, it would have a lithium atom, it would have 1 valence electron. If we drew sodium, it would have 1 valence electron. If we drew potassium, it would have 1 valence electron. So what it needs to do is lose that valence electron to become a 1 positive. Alkaline earth metals, so that's your group 2, you'll see they form a 2 positive charge. Then we kind of ignore the transition metals. So groups 2 through 13, 14, they don't really follow the rules so well, but some of our other special groups, so group 15, at least for our non-metals. So those are the ones, the 3 above the staircase. So for this, I'm going to write that. For non-metals, and same with this. So our non-metals, the things above the staircase in group 15, so that would be nitrogen, phosphorus, and arsenic. Those form a 3- charge. For group 16, so for our non-metals, again, above the staircase, that's oxygen, sulfur, selenium, and tellurium. Those all form a 2-. And then group 17, again, that's your halogens. So that is fluorine, chlorine, bromine, iodine. Those all form a 1- charge. So if we were to draw out the Bohr diagram for those things in group 17, what we would see is their valence shell would have 1 empty space. So what it wants to do is gain an electron to fill that valence shell. So a little bit more. It says hydrogen can act as both a metal and a non-metal in that it can either gain 1 electron to fill its outermost shell and become H-, which is a hydride ion, or it can lose 1 electron, so it won't have an outermost shell and it will become an H+ or a hydrogen ion. So you'll see that hydrogen is in 2 spots on your periodic table. They both still say atomic number 1 because they are both hydrogen. So if we drew hydrogen, oh my gosh, what have I done here? So hydrogen has 1 proton. Hydrogen actually has 0 neutrons because its atomic mass is 1.01. So if we drew an atom of hydrogen, it has in its outermost shell, which is actually just that small shell that only fits 2, it has 1 electron. So we have 2 situations that arise pretty easily for hydrogen. It can either gain an electron or it can lose an electron. And so if it gains an electron, still has no neutrons, still has the same number of protons. So if it gained an electron, now it has a -1 charge. Oops. So it has a -1 charge. It has a full valence shell. Remember that innermost shell only fits 2 electrons, so it is full in that it has 2 out of 2. Or it can lose an electron. And you really don't need to draw anything around that. You could draw an empty shell, I guess. So that forms a 1 positive. I don't know why I wrote. Usually I write 1 negative. I guess I'm variable. So just naming those. So this, again, when you have something that has a negative charge, we call that a hydride ion. And again, that's an anion because it is negative. When you have something that is positively charged, we just would call that a hydrogen ion. And so that is the cation of hydrogen. I have a little sticky note in my notes that I see, and I wrote added properties of molecular and ionic compounds. I don't have that with me, so I might do just a little quick video to add on because I think that might be your next set of notes. And then I will post some videos for naming binary ionic compounds. I don't think I have time to record a video today, but I will leave you instructions for what assignments you need to do for these first sections. So thanks guys. Again, email me if you have questions. I'll post some additional videos as well that you guys can look through. All right, have a good one. Bye.